All right, another week, another chat. So this week we'll cover a few different things. We'll talk about cloud in general, and we'll dive into booting and how all that works, and just generally some information about the machine that you might need to know as you bring them up, as you're trying to update them. Just in general, more information. Um, so this stuff. This will be a good reference throughout the week, so do read over it. We'll talk about it and just use it as a reference. But um, anyway, so chapter 3-ish in the book that I used to use, I've distilled all the information that we really kind of need here. Goes over virtualization and hypervisors. And so likely you are in or have taken a computer virtualization class at this point, or have used a VM in general. So I'm not going to spend too much time on it. But right, there's a few different things that you might need to know about virtualization in general, because it's something that you're not going to get away from ever. If you dabble in cloud this or cloud that, or renting services from any company that exists out there, it's a good chance that you're really just getting a VM instance of some kind, or a container of some kind. So, just talking about the basic differences between them. So, um, looking at jails. Jails are this idea that you can run a software in a what's called a chroot, which is really just a little small pocket of storage space on your Linux machine that is kind of basically just a sandbox. It puts you in a situation where if you were to blow things up inside of that little area, then, no big deal. Oh well, just delete that chroot and spin it up again, create a whole new one. This idea still exists in the BSDs. So, a quick reversal on kind of lineage. Linux comes from Unix, and so does another operating system that's very similar to Linux called BSD. And you'll find one of the most popular BSDs here, FreeBSD. That logo has not changed in about 30 years. It's been the same thing the whole time. But they run the same Unix philosophy that Linux runs. If you got into a command line for one of the BSDs, you wouldn't necessarily feel lost. A lot of the commands are basically the same. And one interesting point is that Mac is descended from these BSDs. So Unix, BSD, Mac OS. They don't tend to give anything back, though. The BSDs tend to create software and then license that permissively so that anybody can take advantage of it, and integrate it into their I don't know, software package, whatever it is, and then just ship that. BSDs are so permissive. You don't even you don't have to pay them. You don't have to name them in a lot of cases. It's just free code. Take it and use it and do what you want to with it. Linux took a different path as far as licensing goes. They use what's called the GPL, which adds some restrictions to what you can do with the code. If you add on to the code, so for the GPL in Linux, if you add on to the code, you have to also release your code under that same license, which means that other people can use that code. But just generally, those are the differences between the two. BSD will generally be more permissive. As you look around, if you ever ask that question, like, well, so where do you use BSD? Why is it still around? Why is it popular? Netflix uses BSD. So they will, I think that's just one of the things that you'll run into when you ask that question. Just about everything else on the internet, though, Linux. So anyway, jails are this idea that you wall off a part of your operating system to run some software so that nothing gets in and nothing gets out without your permission. That is the idea of a jail. And this is really what gave rise to what we now see as containers, as Docker. essentially. Docker is one of the big ones. You have Docker really actually lives on a Linux technology called LXD, but the idea is the same. It's a walled off partition of your operating system that you can run a piece of software in. But jails really came from the BSDs. Virtualization, however, is a step, I guess, more complex, a more complex step, because virtualization doesn't just wall off stuff, which it does. It lives on top of the hardware and directly uses the hardware as well. So in the case of RAM, so you're running a VM. When you start that VM up, the RAM that you assign to that VM on, I guess, less complex hypervisors like VirtualOx. So say you give 2 gigs of RAM to a VM, it's given to that VM. It is no longer available to the system itself. When you get into more complex hypervisors like Hyper-V and VMware, you run into a situation where you can utilize what's called dynamic RAM, which works kind of the way that it sounds. The RAM that is used in the VM is what is taken from the system. However, everything is still available to the system itself. So, for instance, if your Linux VM is allocated 2 gigs of RAM, but is only using 1, to the system, it's really only using 1 gig of RAM. The host system itself can still use the other gig of RAM. Let me see. All right. So VMs in general, as they grew in popularity, we needed to find ways to really kind of just clone them, make them easy to use and portable. That's one of the cool things about a VM, is that it is portable. If you have one hypervisor, say you've got 3 machines running Hyper-V, it is trivial to either clone or just back up a VM and move it to another hypervisor. Say you're taking a hypervisor down for maintenance, or you're just decommissioning the thing. To get the machines that run on that VM or on that that hypervisor is fairly trivial. Just move the disk and the configuration to the next machine, which is most of the time just 2 files, just the hard disk itself, whatever you created, and the configuration. If you have additional hard drives, you got to move those too. But generally, it's a fairly simple process. It's made even simpler when you introduce these formats, these types of formats. Open Virtual Appliance and Open Virtualization format. So VirtualBox and VMware tend to use these. So an OVA is a collection of all of those things that I mentioned, the configuration, the storage, all of that stuff, everything that you need to run a VM that's already been configured. It's all there inside of this OVA. You can think of OVA kind of like a zip file. It contains a bunch of different stuff that you can move from one place to the other. The other really nice thing about these types of files is that you can spin up multiple of the same thing. So let me see, I've got it downloaded. Downloads, there it is. So, turns out I already had it. Anyway, you can see here, this is the OVA that we're going to be using in the lab. It's about 4 gigs, and when you, if you're using VirtualBox, you just double click on the thing, and it will import it. It's got a lot of information in it. I mean, this is all the configuration stuff that is stored within the OVA. You can create them yourself. It's fairly simple, especially in VirtualBox. But yeah, I mean, this is quite literally as easy as it gets. Double click on the OVA, click import. That's pretty much it. You've got a new VM. I cancel it, but once you import it, you have to agree to the license. We'll come back in about 2 minutes. Check on that. 2-3 minutes. Anyway, we'll have a full-on system that we can use. Well, to do Kali things, I guess. If you're into security, penetration testing, things like that. Kali tends to be the operating system that's recommended most. But anyway, in the cloud, this happens a lot. You have pre-configured VMs that you sell to customers. When a customer logs into your portal, so say that's AWS or Google Cloud or Microsoft Azure or one of the other smaller players, a lot of times they have pre-configured solutions for you. Say you are looking for a WordPress instance or even something like a Moodle instance. These things exist. You can create one of these for yourself or your company or whatever you're doing. Or you just want to do some quick blogging, so you want to spin up Ghost. Whatever the case may be, there are options within those cloud providers where you just one click. A lot of times they're called one-click apps. Click on the thing, click next. About 5 minutes later, you're emailed or on the screen that you're on, you're just given login information. They make it even easier a lot of times, but we haven't gotten to that point yet, so I don't expect you to understand the key exchange. But they basically give you a certificate that you can present to log into the VM instead of using a username and password, or in conjunction with using a username and password. Using certificate-based login is way more secure. Think of like a 200-character password. That's basically what that boils down to. Anyway, that's kind of the idea. That's really what I want you to get out of this VM idea. You're going to get hammered with VMs throughout the semester, so a lot of these ideas will become more and more clear to you. But just know that in a lot of ways, what you're doing here by importing an OVA is very similar to what's happening when you go, spend $5 a month on Amazon Web Services to bring up a small WordPress instance, so you can, jot down your notes, remember things that you've done throughout the semester or throughout your career. I host a website that does exactly that. Just those weird, obscure things that I run into that I know I won't remember in about three weeks' time, but I might run into that issue again. Just write it down, put it on a website, leave it there, and then go to it whenever I need it. But the upshot to that, this doesn't matter where I'm at in the world, right? I can access my own website. Anyhow, so you take that further, right? So you have these VMs, you have these containers, you have all this cloud infrastructure that you're dealing with, and now you have to figure out a way to manage it all. So a lot of times, that's going to be one of these things. Cloud Init, Anaconda, Kickstart, Puppet, Chef. There's another one called Ansible. This one is becoming more and more popular every single day, simply because Ansible takes about an hour to get set up for your enterprise versus something like Puppet or Chef that take... if you've got a Puppet or Chef engineer on staff, obviously that's what you're going to use. But it is way more complex to set up Puppet and Chef. But I mean, there are benefits to that. It can do way more. But the idea behind all of these things is the term configuration management. You want all of your machines that are running to be consistent. So let's say that you are one of these cloud providers. You do Amazon Web Services or something like that, and you want one WordPress instance that someone paid $5 a month for to be exactly the same as the next customer that pays $5 a month. So configuration management is the idea that you're going to, say in this particular example, you're going to bring up Apache. You're going to have it listen on port 80. You're going to allow it to only have 200 clients at a single time. You're bringing up the services. You're pointing it to configuration files just to make it consistent. So every time you say, fire up a VM or a container that is running a web server called Apache, it's going to be the exact same as the one that you did 5 minutes ago, and as the one that you did 5 days ago, and as the one that you did 5 weeks ago. That's the whole point of all of this stuff. Anyway, so this is just another example of what that configuration management might look like. I believe Jason or JSON is the... I'm probably going to get this wrong now, actually. I think that's Chef, but it may be Puppet. I cannot remember. But this one's definitely Ansible. YAML is definitely Ansible. So anyway, it's the same kind of idea. You want everything that you spin up to be exactly the same. So those are things that you're going to hit more and more and more of in more cloud-focused classes, but that's the basic idea. So provisioning storage, this is something that you'll run into every time you create a VM. The difference between dynamic and fixed storage. Anyway, the idea behind dynamically allocated disks is that when you create a VM, and if you've chosen dynamic storage, your hard disk will probably be about a whole 8 megabytes once it starts. Once you get the operating system installed, that will balloon up to however big the operating system is. In a lot of cases, Ubuntu is going to be fairly small. Let me see. Actually, I will show you. Oops. Mine are all dynamic, so yeah, get out of here. Mine are all dynamic, so let's see if we can. Let's see if it tells me where they are. Oh yeah, actually, here we go. Here's a big old long list. So inside of the manager, you can see, say, my Ubuntu VM that I created last week. I've given it 20 gigs total to grow, but it's currently only using 5 gigs. So on my system itself, so my actual physical hard drive in my laptop, we're only using about 6 gigs to store this VM. It can be up to 20, but it's not. It's sitting at 6. That's the beauty of dynamic, right? You can kind of oversubscribe your disk. You can, say you have 100 gigs total in disk space. You can allocate, 20 gig disks for way more than 100 gigs, as long as each individual disk does not grow beyond 100 gigs total. Fixed is the opposite of that. It is quite literally telling you, if you say 20 gigs on the disk, it will be 20 gigs on your physical hard disk in your laptop or your desktop, whatever you're using to run the hypervisor on. So just keep that in mind. The difference, really, I think, is going to be one of performance. A fixed disk will perform better than a dynamic disk. Reason being, you don't have to waste the CPU cycles to allocate the disk as needed when you're doing stuff like installing updates or downloading files or something like that. The storage is already allocated. And further, if you remember in your operating systems or your PC hardware class, I'm not sure which one covers it, but you're talking about fragmentation. If you do a dynamic disk, there's a chance that your disk can become fragmented as you add stuff to it. So if you download a file or something like that, a big file. Windows in general tends to just be really bad about fragmentation. NTFS is not a great file system if you want to keep everything as easily seekable as you possibly can. But with the proliferation of SSDs, it's becoming less and less of an issue overall. But spinning disks still exist, so yeah, it's not a great situation for them using dynamic. But a lot of times in situations like ours, where we're not really doing a whole ton of stuff with our VMs, you don't really feel it. VMs that live for a long time, that become very, very fragmented, that's really when you'll feel that that crunch, I guess. Anyway, you might see it also labeled as thin and thick. So thin being dynamic, thick being fixed. Networking, you'll find a lot of different ways to do networking. I think VMware by default does what is called NAT networking in VirtualBox, but the idea is everybody gets connected up to the same network on the VMs that you bring up, so they can all talk to each other. VirtualBox takes an extra step and isolates everybody. So when you create a new VM in VirtualBox and you fire it up, it does have a connection to the internet by default, but it does not have a connection to other VMs that may be running on the system at the same time. You would need to move to NAT network in that case. But VMware doesn't add that restriction. Everybody gets dropped onto the same network at the same time. So, if you brought up two Ubuntu servers, they would both have connection to the internet, and they would both be able to ping each other, SSH into each other, which is a remote control protocol. So, one server could log into the other server and issue commands. You can also do stuff like local host-only networking, which is the idea that the VM doesn't need to touch anything networking-wise, but you on your system can log into that VM. So it's basically just an isolated way to run a VM. If you just want to test something or something very quick, it's an easy way to do that. And if you have like a clone of your system or an OVA, as we were talking about before, it's very easy to set one of those up and then just use it really quickly and then tear it down as you need. Bridged is one of the more useful networking capabilities. Bridged basically allows your VM to sit on your network card, as in use it for real. And the benefit here is less latency. So when you are using the defaults in both VMware and VirtualBox, you'll run into a situation where you basically have to be routed to get out of the network that you're on at the beginning. So it's an extra network hop. And if you've had any network classes up to this point, you know that every single network hop adds a few milliseconds of latency to the time it takes to get to your destination. And by removing that, it's probably not human perceivable because you're shaving off a whole 3 milliseconds, but 3 milliseconds on every single packet that you leave, that you send outside of your network interface, it adds up. It adds up. So using Bridged removes a lot of that gap, but removes also a little bit of the protection that you get from that as well. However, so as long as you have a firewall configured, or you have an idea of the types of network traffic that this VM is going to see, then you'll be in a much better spot than just flopping it onto a bridge network adapter and calling it a day. Realize that puts that on the actual network that you're running on, the physical network that you're running on. All right. Containers. So we were kind of talking about this earlier. This is really where jails kind of turned into. BSD still uses jails, but can also use containers as well. So jails gave rise to LXC. LXC gave rise to Docker, and Docker is the dominant container format that you have out there on the internet. One of the cool things that you can do with Docker is, once you get to know how it works, you can run entire stacks of software within Docker. So, like I said, Docker is just a container format, and Nextcloud, for instance, is a Google Drive alternative. So by default, you really just, it's a cloud type storage solution where you log into it through a web interface. Here, let me see. I've got one myself. I run one here at home. It's really convenient to just have this. And it's